Okay. When there's no magnet near a compass, where does the compass point?
North.
North. Okay, so let's take a look at the compass. Which way is north, according to
The red one.
Let's all point.
That way.
Okay, so everybody see where the red is, or where the big arrow is pointing in this direction. So this way is north. What happens when I bring a magnet near the compass?
It points toward the
It
magnet.
follows.
Okay, so here I'm attracting the north end of both compass. See, this compass is pointing with the red towards this end. And if I bring it to the middle, the compass actually points towards each other, right? If I remove the magnet, where does it go?
North.
Okay, can everybody see that it's going back to north?
Yes.
Okay, now, if I place this device, or this compass near this device, where we have a battery, copper wire coiled around an iron core. What do we call this?
An electromagnet.
We call this an electromagnet. Why? Because
It could be turned off.
As north and south poles.
it becomes a magnet. So here we know that a compass gets interfered by a magnet, right? When I place a magnet, the compass no longer points north. Is it pointing north now?
No.
No.
No, where is it pointing?
Towards the magnet.
Towards the nail or the magnet here. Why? Because now
It's magnetic.
this has a magnetic field, okay? What happens if I disconnect it?
It
Turns
turns
north.
when it goes back to north.
Okay? It'll turn off and it'll point back to north. Before I turn it off, I want to point it out. Here I have the plus end connected to the side nearest the head. Okay? Here I have the opposite side connected to the head. So when I place the compass here, what point of the compass points to the head?
The south.
So.
The south end. Can everybody see that?
Yeah.
South end. What do you think is going to point to on here?
North.
North.
Why the north?
Because that side is now the south pole.
Okay. I've switched the battery, which switches the...
Poles. Current.
First it switches the current, and then it switches the poles of the magnet. So, let me place the magnet, the compass over here. And notice what point of the magnet is pointing to the head.
North.
The north. So what do you think is going to happen if I move the compass here?
The south.
What do you think?
Turns
If this is the north end, what do you think is going to be on this end?
south.
So let's try. All right, did you guys see that?
Yeah.
So now we have the white and the south end pointing to the tip of the magnet. Okay, any questions so far?
This is my video.
No. Okay. When I remove or disconnect the battery, should this have any magnetism?
It takes a while.
It should not have any magnetism, but you see that the paperclip is still attached. So what's happening to the domains?
They're kind of
Unorganized.
They're becoming more unorganized,
slowly.
but slowly. Okay? Now, there's a couple of differences between this and this one. Here I have a bigger nail and a bigger battery. So, according to your labs on Friday, which one should pick up more paper clips? The one with the bigger nail and the bigger battery. What are the 3 ways to increase the strength of the magnetic field?
The more coils, bigger now, bigger the more.
Okay, increasing the number of coils. So if I put more coils around here, what's another way?
The battery size.
Increasing the battery size, what's another way?
The nail.
The nail.
The size of the nail.
Bigger nails.
Okay. Anybody have any questions? Okay, go ahead and stop recording.